Hello everyone. So I'm Deepak Raut. I'm the Chief Engineer for PowerX Product Development Team, and I'm here to introduce to you the Hypercharger range of products what we have from our side. So let's get started with the first product introduction video. Okay, so now I would like to explain to you about some of the most salient features what we have in our hypercharger. And to begin with, it's very important to know what the hypercharger stands for and how it was conceived and what are the key features, what we plan to have it, and possibly what is our future roadmap, how we plan to enhance and build upon it. So this is how it all started. The most important thing is, like, we know there are chargers everywhere. There is a promotion of electric vehicles all around the globe. There is a need for going towards zero emission. For most of our nations, this is very important. Even for Japan, is planning to build up to carbon neutral systems by 2035. And this is where the role of renewable energy into electric vehicle charging becomes all the more important. What we bring in, what the hypercharger brings in, is basically possibility to store renewable energy in our batteries, which are cost effective, size efficient, and this is how we fit into this ecosystem, where we allow you to store your all the energy from renewable sources instead of just taking it from the grid. And we give you the capacities in many scalable formats, which you can just build upon and have your configurations for the desired capacity and power output. Now, all the more, while doing this, we know that we can have very high power chargers. There are a lot of them existing today around the globe, not so many in Japan, but the primary problem with such chargers is basically to have a very high input power requirement, which is basically a problem for the grid and the local installations. And now we solve this problem with the possibility to do it with just low voltage connections and a very low power grid connectivity option. And all this is possible with our scalable architecture. And now the most important part is, when I say scalable, we mean basically you can think of any capacity and we can bring that to you. We can charge cars, we can charge transport systems, we can charge. When I say transport system, it can be public transport, big trucks and buses, all of that is possible. So because of the size of the battery what we have, we can be much bigger than what is needed just to charge a car. Now, this brings us, gives us the advantage of being low on installation cost, at the same time on operation cost. We do not really cycle the battery so much. We will come back to those points in a short while from now. Next, summing up the benefits, since I spoke about batteries, and batteries are quite essential to the range of chargers what we plan to have. These batteries are not coming from anywhere else. They're coming from right here in Japan, from our production facilities, taking advantage of big volume purchases and also great automation facilities. And this is what makes us bring that at a very cost efficient proposal, give you a very cost efficient proposal. Right from our factories. So this is one more benefit which sums up what you get from the hypercharger. Now these factories, what we're talking about, they leverage the strength of Japanese manufacturing, and they have a high, they ensure the level of quality, what has been proven by Japanese manufacturing since decades now. And we leverage upon that, and this is what you get with the hypercharger. Now, I clearly mentioned that we are truly carbon neutral. And this is what we stand for. And that means we are not the ordinary EV chargers who rely on the grid and probably take a lot of energy from the conventional grid from non-renewable resources. But here we are, where you can integrate a PV array, a wind power source, or any form of renewable energy systems, which is ensuring the carbon neutrality, what we all strive for. Now, how do we do this? The most important thing, what I want to mention here, is we have a specific mode which we call the dual mode, and we all know that if we have power from the grid, we can charge a EV. We have power from a battery, yes, we can charge the EV. But what we do basically is like combine the advantages what we get from both of these, charge the EV while we are also possibly charging the battery if the battery needs it. And this allows us to reduce the number of cycles what we do with the battery. And for those of us who are familiar with batteries, they know it very well that cycling the batteries less gives us a very long life and makes us very cost efficient in terms of operation. So this is what is dual mode all about. Now, if you understood the architecture, I have given a brief description of the architecture already. So we have a battery, we have the grid, and we combine both. And during the daytime, probably, for example, if you are connected to a PV array, you will have lots of renewable energy, a possibility to store a lot of renewable energy from such a bright day like today. You can have a lot of energy stored into the batteries, and then you can use the same energy to charge your cars, and possibly not just during the day, but throughout the day and night. Now, dual mode simply means less number of battery cycles and longer life, and this is what I want to mention as one of the key benefits what you get out of our chargers. Now, the architecture is very scalable. It's not just that it comes in certain configurations. You can choose what kind of input capacity you need from the grid. It can be as low as 20 kilowatt to as high as 350 kilowatt and even higher. Basically, we have a scalable configuration of AC-DC stacks and DC-DC stacks, and all of this is controlled by our own inbuilt controllers. So we have controllers which can scale based on your requirements and probably provide you the desired output for a specific input and give you a scalable configuration of the battery also to combine along with it. Now, as we know today, we are familiar with the terms like quick charger, normal charger, fast charger. What we bring in is also, we don't put it into any of those categories, but just to give you a quick overview about the industry itself. When we say slow chargers, we are generally talking about the chargers what we usually use at home, basically 3 to 6 kilowatt and possibly charge it overnight. But none of us probably have that kind of a patience today, and we would like to move towards carbon neutral future. We want to do it faster. So this is where the role of quick chargers come. And we know that with quick chargers, with output of tens of kilowatt, we can charge our cars faster. But with the hypercharger, we take it one level up and we try to do it. We try to not just charge, but basically we try to hypercharge your car. Now coming back to the incentives of usage of EV. So there is a need to use more and more of the renewable energy sources. In case of EV charging infrastructure, this is what and then do the same thing in a very, very fast manner. This is what is our key objectives and key features what we want to have as a base for our hypercharger. So we reach ultra fast charging levels and still use renewable energy. This is combined together. They give the greatest benefits not just to us, but not just to our customers, but also possibly creating a sustainable future for going forward. And this is the base of the design concept. Now coming back to how large output from grid makes difficult installation. I think we all have seen this. If you have to do an installation for a high power charger today, you'll have to look for very big transformers, and probably you'll have to get a leased line which can go up to probably 350 kVs and even higher. And this is where the hypercharger comes to rescue. We can do the same power output. We don't always need the 350 kVA lease line or even a huge transformer installation. We can do all of that from as low as a 20 kVA transformer, or even just a 200 volt single phase line to begin with. Depending on your needs and the kind of charging time and the kind of storage battery capacity you need, all of this can be optimized, and we can give a very customized solution to you to meet any of your requirements. Now, this is all explained in a manner, but I need to also tell you about one of the barriers which was there until today. Now you might be wondering that if all of this was so easy, why nobody else did it, like in the first place? What were many companies waiting for? So the cost of battery was one of the one other determining factor. Now we do that and bring the volume benefits and the automation benefits from our manufacturing assembly. We do that in volumes. PowerX plans to use the same type of cells and similar kind of battery formats in many different applications, and this gives the advantage of the volumes what we make and brings the battery at a much cheaper price. And now this is what enables us and keeps us in a much better position to provide you this unique architecture of ours with scalable battery configuration, keeping always the cost of operation and installation quite low. Even if you do not rely on the grid, doesn't mean that the battery comes at a great cost. So it is still achievable with our batteries. As I mentioned before, this is quite scalable. Now how and where do we manufacture this? Here we just need to mention we all are sitting comfortably here in Tokyo, but then we have many unique places in Japan. I, as a foreigner, I came here, I got to know about Japan, and this is where I know there is a lot to explore. And our unique team is setting up a manufacturing facility which has already started in Tamano City, Okayama Prefecture. And this is going to be one of the largest battery plant in Japan with a plant capacity of up to 5 gigawatt hour. And with a solid R&D center planned around it, and with a focus to develop the local skills and bring in more talents, I think we are planning to be a workplace where many of the younger people and also experienced people would like to join us in our endeavor for a sustainable future. And this is where the factory of the future comes with sustainability goals, and we look forward to bring it to a scale where we are probably much sought out in terms of development, manufacturing in Japan, and bring products of a global scale from Japan to the world. Okay, so now the factory is located in Naoshima, and it is closer to the Satochi International Art Festival. The factory itself has been built by one of the world-renowned architects. Many of you must be knowing her, Kazuyo Sezima, and I think she reflects clearly in the design, the beauty of the location itself, and this is where we feel that the design, if you see it, will make the workers feel like home and probably want to work with us. Now we need to talk a bit about the safety. We just don't think that technology itself is just an enabler for efficiency and performance. Technology itself is an enabler of safety as well. So what we bring in is basically the safest batteries around. And we all know that when we tend to think about batteries, we tend to think about fire, explosion, and maybe this general sense of lack of safety, what a battery storage system brings in. But our cells, with our own battery management system, our own charge controllers, and our own energy management system, are all of that developed in Japan with the utmost level of cybersecurity benefits, having the security what is needed for any kind of data and communication, and even with our backend operation and compliance with the latest charging protocols, not just CHAdeMO from Japan, but also looking towards into the future of the charging protocols, CHAoG, MCS, CHARIN. We are part of all those working groups where we work to bring in the kind of controllers for our batteries with the right kind of cell. All of this with a LFP cell, and that we are trying to commonalize across all our applications and products offerings, which brings the level of safety to let you know that we do care about our customers who want to use such products in their applications. Our applications also enable us to have the latest form of interoperability between different charging stations. So we just don't sell the batteries and the chargers. We also have our offering, which is compliant with OCPP 2.0.1, which is the latest interoperability standard for applications or backend systems which support EV charging networks. And with all of this possible, it is also okay for us to customize a solution for you so that you can use your own charging systems with our IT networks and possibly get the benefits of IoT, machine learning, and AI, what we plan to infuse as we go ahead with our development plans. So I have been talking about the modes of operation. Okay, we can do battery to vehicle, we can do grid to vehicle, we can also combine both, which we call as dual mode. All of this can be controlled without any complicated procedures, just by using our apps, which gives you everything on your fingertips to just be as informative as possible if you need it, or maybe as simple UI interface to just to know what you really need in your day-to-day operations. So thanks for listening to me this far. So far we have been talking about putting the power from the grid, from the renewable sources to the vehicle, but we also plan to build in functions which support emergency operations. That means we try to store power back from the vehicles or maybe some different sources directly back into a battery. So our batteries don't just charge vehicles. They also can store energy in case of emergency and provide support emergency lines when needed with the support of features like bidirectionality. We do that with EV POSA guidelines from CHAdeMO in Japan, and also the various smart charging features from ISO 15118 to support CHAdeMO and other operating bodies. So V2X and V2G is something which is probably, we will be one of the very first few chargers who can do it up to more than 10 kilowatt. Now, we need to talk a bit about the creative design what we have. So, along with the technical efficiency and the performance what we get, we also have all of this done in a very creative manner with the kind of exterior designs which blends into the surroundings and probably can be customized to many different sceneries where our users would like to probably use it in a parking lot, or maybe next to a shopping station, or maybe a highway parking location. All of this is possible with the great Japanese craftsmanship what our team brings in, and with the creative designs and the UI UX designs what we work on. And all of this will be combined with smart charging features and probably will make your user experience all the more intuitive. Next, I explain to you how how to use the hypercharger. I think we can go through a short video for this. So that was it. I think you can now understand how easy it is to operate a hypercharger with our apps, and it's just a matter of using certain authentication, and probably some measures for your safety, and then probably you can enjoy the hypercharging, which can be real quick. All the more, I will like to just take you through some briefs about what a hypercharger is capable of today. So we have hypercharger which can do 90 kilowatt continuous, scalable up to 350 kilowatt based on demand. Right now we have already reached 150 kilowatt with our existing offerings, and maybe some of you already are aware of what an extended feature means. So there are not many chargers which implement this, but today we have dynamic control, high current control, and high voltage control, all of them enabled. We can go beyond 500 volt. We can also go up to 1000 volt, and we plan to introduce prototypes very soon with 1500 volt capability to match the latest charging protocols with the cooled cables, which will enable you to use lighter charging cables, lighter charging connectors with the ease of operation what you want in your day-to-day applications with your EV, and possibly very smaller cables. So all of this is possible when we move towards our next intuitive development phase, which is with charging prototypes, with cooled cables, and 1500 volt capability. Now finally, talking about the schedule, we don't want our customers to be kept waiting for our products, so we have started taking advance orders already, and this is how the milestones look like. So we already started the pre-orders. we promise to deliver on these orders by around middle of next year, and our mass production starts early 2024. So that is all from my side for today. Thank you very much.